Okay, good afternoon everybody and welcome to Stream A, which is going to be all about future technology. I'm going to be back up in a minute to introduce and set up the panel discussion. I'm Paul Waller, one of the Principal Technical Directors in NCSC Capability. But my first task is to introduce and welcome our stream sponsors, Ultra, to say a few words before the panel. So guys, if you want to come up on stage, we'll get started.
Good afternoon. I'm Simon Kroll. I'm Vice President of Business Development and Innovation here at Ultra Intelligence and Communications. And today, I'm going to be talking about microelectronics and hardware that is at the root of so much of our digital lives and drives forward all the time innovation and increasing efficiencies in use of electronics, power, and software. And it is on that last one I'd like to draw attention to, because at the moment, here in the ICC in Birmingham, we stand at sort of a nexus where the value coming from software is ever increasing, and it's driving advancements in the microelectronics themselves, be that better efficient use of them, or even the design of those pieces of a microelectronics. But there's something even more fundamental than the software, the hardware around securing our digital future. And that argument I'd like to make today is access to reliable, sovereign, efficient, sustainable power. And power is where I'd like to hand over to Gary.
Hi, I'm Gary, a software engineer at Ultra INC. And as a software engineer, what matters to me is access to processing. So what does the future of microelectronics mean to me? Well, as we know, large data centers already provide a tremendous amount of processing capability, but at a huge cost of energy, with data centers in 2022 estimated as using around 1.8% of the entire world's total electricity consumption. That's more than France. And in the UK alone, in 2020, data centers consumed 3.6 terawatt hours of electricity, which was more than twice the domestic consumption as Birmingham. We see energy as becoming an increasingly vital metric, not just at edge devices relying on charge management, but at grid-plumbed-in data centers too.
Hi, I'm Khalid, a graduate software engineer here at Ultra INC. And that consumption that Gary talked about is only in an upwards trajectory. This is with the likes of AI and, say, an NVIDIA H100 that has a utilization of power of 61%. That equates to over 12,400 miles in a Tesla, or over 1,900 times around Birmingham's Middleway, the A4540. times out by millions deployed, and that's a busier jam on the middleway than at any rush hour. Quantum computing isn't power efficient yet, so there's no savior in sight. And these worldwide energy consumptions by data centers in 2022 are estimated to more than double in 2026. So it's not hardware that's limiting these data centers from expanding. Sure, it's the need for space and capital investment up front, but it's not the barrier for space availability or mature business cases for ROI. So what's limiting? As we said, it's access to cheap, can I say green too, energy, as we're witnessing in Holland and Singapore, where they're introducing energy caps to new builds of data centers due to issues with access to electrical power. Although Singapore have subsequently lifted that cap, access to power still remains a fundamental issue.
But if we look forward, taking efficiency from, let's say, 1945, where in this picture you see the electronic and numerical integrator and computer, that used about 150 kilowatts to do its operations, or about 30 watts per operation, addition operation. Nowadays, with the advances in microelectronics, making them smaller, faster, etc., that efficiency is down to nanowatts, low nanowatts per operation. And we're seeing that throughout our own electronic products, that we're able to keep up with the demand, the ever-increasing demand, through efficient use of hardware and software on these types of devices. But as Khaled and Gary have already said, that power can be a limiting factor, and the access to that power is vital for us in the future.
So how do we make the best use of that power to ensure sustainability and security?
I'd like to take a look at where value from the availability of the available power comes from, hardware and software. If we take a look at this diagram, we conjecture that initially, to an end user of computing capability, all of the value came from hardware. But through the years, this has transitioned to software with the advent of transistors through to microprocessors and the likes of H100, which Khaled mentioned earlier.
So if we look at the top right-hand side of the graph, we see various cycles where hardware and software cycles through different values. Obviously, the absolute value of the hardware is ever increasing, but perceived value to a user may alternate, and this may come with refresh cycles of new hardware coming in. We're also going to argue that those periods are increasing in time as things like firmware updates and the effort required to introduce new hardware actually increases. But as we go forward, we see software is vital to the value that it's adding there.
We posit that this demand is in an upward trajectory, and that software is the linchpin in addressing this efficiently. It's the realm where value is increasingly being delivered based on abstract and generic hardware platforms. Software is not just a component, but the driving force in our digital landscape.
We see a level of value given by software and hardware, and we are arguing that power efficiency is an increasingly vital metric for these. But what role do these play in delivering cybersecurity, which is, of course, why we're here today? At Ultra INC, we are looking at putting more of our security into the software layer, whereas traditionally, as a secure communications company, a lot has resided in hardware, with bespoke designs and anti-tamper measures, for example. This is clearly costly in terms of development and needs to be amortized over a large number of units. We want to be efficient where we can and make use of generic, reusable hardware. And we're achieving this by putting more of our security into the software layer. And we're using the application of secure programming languages such as Rust to accomplish this. Rust is a programming language that many of you will know is gaining popularity to its memory safety model, and this is something that was picked up in this morning's plenary as being critical to security going forwards. Its concepts of borrowing and ownership provide assurances at compile time that a safe program will not misuse memory. These kinds of prevented violations are commonplace in memory unsafe languages such as C or C++, and are estimated as accounting for more than 2/3 of common security vulnerabilities and exposures. Eliminating these kinds of vulnerabilities is a huge win for security and a great step when adopting secure by design principles. But does this added security come at a cost? By verifying memory use at compile time, Rust is able to achieve and maintain the performance of unsafe languages such as C and C++, while giving you assurances that you would normally find in managed languages like Java, which is normally significantly less power efficient. This is great, a win-win where power efficiency and security objectives are perhaps surprisingly aligned rather than coming at a cost of one another.
I'd like to pick up on this last point. As we said, it comes down to demands of power and processing itself. So what additional burdens does a secure software place on an approach? People will be more reluctant to pay more for security, perhaps, but they'll sure pay less. Rust initially does have a steep learning curve for engineers, but as power is becoming an increasingly key economic motivator, organizations are incentivized to invest in their developers in upskilling them and making use of this more secure technology.
But earlier we mentioned that there was a cyclical nature between hardware and software. So what about the innovations around hardware and the efficient use of that we've been looking at Ultra recently?
Cherry, or the snappily named Capability Hardware Enhanced Risk Instruction, provides more secure applications while working on the Morello competing demonstrator platform that Ultra have been involved with the past few years and the UK government have championed. Cherry is an extension to a RISC architecture that replaces memory addresses with capabilities. Memory addresses refer to a data of location in memory. Capabilities not only store that location of data in memory, but also act as an authorization token with permission to access that memory. Unlike addresses, capabilities cannot be forged and must flow through the entire system of its individual parts, being able to monetically pass a decreasing subset of its own capabilities to the intended recipients. The result is a system where at every point of execution is only able to access the data where this access has been made available to it. This is a much finer grained level than process memory isolation and can even catch memory misuse within the logic of a single process. For example, buffer overflows.
The security benefits of an intrinsically secure memory model are clearly apparent. But as with Rust, does this fine-grained security come at a cost? Well, again, thankfully, these objectives are aligned. And with Cherry, the architecture introduced by Cherry actually has the opportunity to improve power efficiency in some areas. For example, a traditional operating system without Cherry must achieve this data compartmentalization by restricting regions of memory to specific processes. This comes at a significant execution cost, especially when a processor has to switch back and forth between the often hundreds of processes running at any one time. Cherry is able to achieve this compartmentalization without such expensive context switching and can even do it within the logic of a single efficient process.
And in conclusion, what do we take from all this? What do we depend on for our own digital security? And what does the future look like, the future tech that we're talking about today? Well, fundamentally, we think it depends on three things. Firstly, power. The lights were meant to go out then, that would have been good. Power, which would be making the best use and efficient use of the power that we have available and ensuring that the UK and other nations have their own access to sovereign power.
From software, we need a robust, secure by design approach, and we need to champion in the UK the use of secure programming such as Rust, and to make sure that the tools and support are available to make the UK a centre of global talent.
With hardware, we need access to platforms that support energy-efficient processing. We need to invest to ensure access to and drive efficiency and security in their use of power. Innovative technology such as Cherry, miniaturization, storage, material science all play a vital role in getting more capabilities out of the power that we have access to today.
And how will it all look in the future? Well, we can only see demand increasing in the future and continuous advancements in efficiency and innovation around the better use of hardware, software, and getting more from our power will be vital to meeting that demand in the future, along with making sure, as Gary pointed out, that the skills and resources are available to do that.
From all of us at Ultra INC, thank you. And now let's find out what the panel think.
Thank you.
Hi, everybody. Can you hear me? All right. I am Senior Technical Advisor from CISA, Bob Lord. And maybe what we can do is just kind of go down the row and just briefly state your name, affiliation. They can Google you later.
All right. Hey, I'm Dave Weston, Vice President of Operating System Security at Microsoft.
I'm Sadie Creese, Professor of Cybersecurity, University of Oxford.
Sean John, Chief Technology Officer, NCC Group.
Anjana Rajan, Assistant National Cyber Director at the White House.
Okay, so now you know I'm so excited to have these folks at this panel. So let me just set the stage a little bit. So a year ago, CISA introduced the Secure by Design white paper, and we received just a tremendous amount of feedback from industry players, customers, you name it. And based on a lot of that feedback, we produced a second version of that white paper in October. and we started to do things like release Secure by Design alerts, which were really just very tailored products associated with specific classes of vulnerability. We're going to go deep on that topic in a minute, so that's a little plant there. And one of the things that we really wanted to do is really introduce this idea of not just playing whack-a-mole with individual product defects, but to really understand the root causes for some of these things. And some of you may be familiar with a paper from 2007 that MITRE produced. It was called Unforgivable Vulnerabilities. And in it, they described a series of tests that you could apply to figure out if a particular kind of coding error was forgivable or unforgivable. And then they came up with 13 vulnerability types that they thought met the criteria of unforgivable. It's pretty bold. Yeah. Pretty bold, pretty bold, pretty bold. The consensus of the panel is pretty bold. Would it surprise you, it's not going to surprise you because you're here in this audience, but hypothetically, would it surprise you to learn that in 2023, if you take a look at MITRE's, again, MITRE, their 2023 stubborn weaknesses, which were classes of vulnerability that had been at the top of the list for the past 5 years running, would it surprise you that those unforgivable vulnerabilities from 2007 were mostly the same in 2023? Probably not. That's why you're in this audience. And yet, this is a sort of thing that we haven't really taken stock of in this industry. And so a lot of what we want to do is think about why that is. And economics keeps popping up as one of the things that happens over and over again. And so we wanted to talk a little bit about some of the experiences that these folks have had, but we also wanted to talk about the underlying market incentives for creating change. And so I think with that, I'm going to start with you, David, because you're kind of like the software guru.
Okay.
You work at a software company, true?
True.
True, okay.
True.
So like one of the things that you hear about in other industries, in fact, earlier this morning, there was a talk on OT, and they started talking about the Kaizen, continuous improvement, lean product management, and all of those kinds of things, which are well established in other industries. We don't really have that as a pervasive concept in the world of software, but I know you've thought a lot about this. So can you tell us, in your experience, how you've measured the cost of vulnerabilities and hard and soft costs, and
Sure.
How do you think about those in economic terms?
Yeah, I think the way we think about it in economic terms is less the cost internally to Microsoft and more of the cost to customers. Ultimately, we're in the software business to make money, and that means that people have to select us. So you have markets like cloud where if there isn't a strong amount of trust, people simply aren't going to give you their data. So we ultimately think about this like it's good business to do security, and we try to calculate around that. But a good example of an OKR or objective or key result, my team would be how many vulnerabilities are we finding before they turn into exploits? How many exploits exist rather than just vulnerabilities, because that would, again, measure across the layer. And we would use those and want them to trend down with the, I would say, market thesis that ultimately customers are going to buy our platform, choose our cloud, buy our devices more often. We're going to be able to monetize better if we have that trend line going down. And we do see evidence of that. For example, we may poll our customers and say, why do you choose a Windows PC over a Mac or vice versa? And what I would encourage folks to think about is the data we get back is a lot more broad than you would expect. So for example, consumers would say things like, I picked platform X because it seems to have less viruses. Translating that into Rust or Cherry is a long stretch, and we got a lot of ways to go.
Magic here.
That's right, yeah. And commercial customers will say, I choose Cloud X because I don't want to get hacked. And so I think one of the challenges we have for this group and one of the calculus to incentivize the market around Secure by Design is we've got a long way to go to educate the market. And frankly, a lot of us just have to choose to build alliances that say this is good business for all of us, without going through the maybe decades-long task of training people on things like memory safety. Right. So I think it's a broad strokes kind of thing.
Yeah, so I understand like the thinking about the customers, that is the focus here, but you do have like an economic driver. Like
Sure.
It does cost more.
Absolutely.
And you hinted this before, when you catch these things earlier, it's cheaper to fix them than it is after it's gone out to deployments.
There's no doubt. We have this concept of shifting left, which is we'll catch more bugs, we'll fix them more efficiently. It'll cost less the earlier in the life cycle we fix it. And so the folks who were up here earlier talking about Rust's compile time advantages, it sure is a little bit of cognitive overload on the developer, but frankly, those are things they should be thinking about anyways. So I wouldn't say the language is more complex. It's just forcing you to do, it's like doing a budget before you go spend money. You should probably do that, right? And so I would say absolutely on any cost measure, and we've done these things internally, it's simply cheaper to find these things earlier in the life cycle, and it has multiple benefits.
And by the way, everybody, just keep it spicy. Like, jump in, fight, argue, do what you want. Free for all. Okay, so that helps orient us a little bit around the software companies themselves. Sadie, people have told me, by the way, I'm just using this as my private panel to get a lot of hard questions answered that I have. So, Bob, tell us about the smaller companies. So the thing is, like eliminating these classes of defect, it can be daunting for a larger company. I'm sure the work that you've done has not been simple. I've gotten this question many times, which is, hey, we're a smaller company. We'd like to do secure by design, but we don't have the resources of the larger company. And this idea of really quantitatively analyzing the cost to shift left is just kind of outside of our scope. Any particular words of wisdom along those lines? And you can feel free to phone a friend as well.
Thank you for defrosting me and getting me out, because I was taught to code, actually not taught to code, taught how to write decent code in the 1990s, so a long time ago, in a place where we worked on formal methods. And everything was actually about building stuff that only did what it was meant to do. Later on, worked on aircraft and such like. Press abort, it doesn't go off. What I would say is this. It's always cheaper to shift left, right? Mm-hmm. Whether you're doing safety or security. If you're working in a SOC, we all know the earlier you detect it, the less harm typically happens to the organization that you're protecting. So shifting left, of course, we can go all the way back to conception. So if I was advising a software company that was small and lean, and what's on their mind is, I'm going to pick this up and use this if you open up more markets to me, if you make it more profitable for me, if you make it easy to do, etc. And all of those things require us, I think, to shift left and to support it all the way back to, and now I teach, of course, in the university, why not demand software engineers that come out of universities with skills that enable them to write code that's free of vulnerability, or at least to write the test suites that check that it's free of vulnerability. Beyond that, of course, let's look to the math. Some of our security testing suites, and many of us depend on security test suites, because the truth of modern situations is our components just part of a bigger stack of components. We're all relying on each other in some way and contributing functionality to each other. So there's lots of black box stuff in there. So we have to test. So how do we know how good our testing is? And actually that brings us straight back to the unforgivable, probably forgivable things, which is don't just focus on the known bad that we've known about for, 40 years?
Yeah.
Thereabouts. We have to be constantly looking towards challenging ourselves, whether there are corners we haven't looked in yet. And if anyone's responsible for security testing, if you think you've got it nailed, then you're too complacent and brittle. So that would be my answer. But I think for the small organizations, get it into the DNA. Mm-hmm. I mean, if the leadership of the small company doesn't believe in it, they won't hire for it,
right.
They won't reward it, and ultimately won't be in the marketplace where it is rewarded. So let's make it profitable and attractive to them.
So one of the things that you said that I really appreciate is we're up here, sort of the subtext of this is secure by demand. How do we get the customers to start demanding that the products that they use don't put them in mortal danger? It sounds like an obvious thing, but obviously it's not. And so you're talking about the demand from the corporations that are hiring your graduates, and they are, I mean, are they asking for security as part of the curricula that the students go through, or how does that work?
I'm not sure they're demanding it, but the students are finding great success when they've studied it.
Yeah,
but security teaching is different to how you develop code that's free from this kind of vulnerability, right? That's software development, and that's about requirements and implementation processes. And kids will be studying that in our environment, even if they don't study security. So we come at it from many different angles. I think it's important, incredibly important, because I've grown up in this other generation. and nobody was asking me whether I'd had those kinds of skills.
Right.
I remember being told they weren't going to teach me to code in C++. I had to teach myself. I was going to be taught how to write code that was reliable and of high integrity, and how to write efficient code. And I'm grateful for that. But do we take such a principled approach? Does everyone feel that way? And do the employers ask for that when they're interviewing, right?
Isn't there an economic challenge that you've got a shipping deadline? And that's the whole thing of, I don't think anyone sets out to write insecure code. They just got a deadline. I know, Ian Levy, when he was at NCSE, used to constantly say, 25 years since you knew about buffer overflows, why do we still have them? It's because you've got a release deadline. So, maybe Agile makes that better. But it's not just about learning it right. Yeah, so it's actually how you build the whole, and how you don't drop testing as part of being Agile.
Yeah.
I love this. This is so much fun for me. And then Sean, so you see a lot of service organizations, and you see a lot from your vantage point. Tell us a little bit about the demand signals and what you see and what you don't see, and just give us some flavor there.
So obviously, as a cybersecurity services company, so we're quite involved in all this, but from sort of the customer side. So whether that customer is the large technology companies or the end customers themselves, it's really going, how do we test it? There's the test that you do yourself, and then, quite often when it hits the real world, it's a different test that comes against it. And that's where a company like ourselves, with deep experts coming in and genuinely trying to break it, including writing exploits to actually prove can we get in, actually can help you to work out how to be more secure. But also when you're talking about secure by design, yes, there's the hardware and the software, but what we're implementing today are complex ecosystems, which is a mixture of software, hardware, cloud systems, and quite often when people get in all those vulnerabilities, they come from the implementation. So it's actually, how do you make sure that you're configuring it correctly, that it's looking at the risk, that you've not just got a checkbox, that you're actually looking at how you not just have secure by design software and hardware, but that the way you're implementing it and connecting it together is also secure. So that's where, from our perspective, there's a lot of desire to do it, but where we are still is that, how do we get that understanding and that control for it?
I totally agree, and I can remember at the turn of the century, we were working, it wasn't in academia then, working with businesses who had invested huge amounts in highly accredited components, common criteria, EAL stuff, and they were still getting done and experiencing quite significant harm. Why is that? Because it's not just the bits and pieces, it's how you orchestrate them, how you use them. We know that. So when I'm thinking about security by design, I think about the organizations that are secure by design, whether you're software producers, whether you're service providers, or whether you're ultimately users, because it's what you do, what you buy, how you buy it, how you test it. It's making sure you have a culture whereby if somebody finds something, imagine being the person that finds something that's a big, costly problem to fix, they've got to feel they've got to raise it, right?
Well, let's be fair, that's part of what our company
Exactly.
does. So
Awesome. Anjana, so you've heard all of this, and you've recently released a technical paper. Do you want to give us a quick primer on that? Because I suspect you have a lot to say on this conversation based on that.
I know you want this to be spicy, but I think we're in too much agreement in this room, so
Damn
I
it.
don't know how spicy it's going to get.
All right. I'm going to work on
you've got
spicy.
to convert it in
spicily
here.
agree.
To make it a bit more of to kind of go back from a national security perspective of why is there a market failure in cybersecurity? I think you have to understand, we think of cyberspace as the fifth domain, and we took a lot of learnings from the other domains of land, sea, air, and did I say the four domains? But space, yes, of course. And we're trying to take the same thesis and apply it to cyberspace. We're trying to define a perimeter. We're trying to erect a boundary, and we're trying to monitor anomalies and alert our way to defense. And that doesn't work in cyberspace because there is no coastline in cyberspace. And we see that because we see supply chain attacks, we see the very security tools being compromised, we see insider threat. And so the whole premise of cybersecurity over the last 2 decades, this is my hot take, Bob, is flawed. And what we need to realize is if we want to think about defense in cyberspace, you have to actually invert the approach. Instead of a perimeter in approach, you need to take a building block out approach. And that's what our report is called. It's called Back to the Building Blocks. And we kind of looked at, the cybersecurity policy landscape, and we spent a lot of our time thinking about kind of the market failure piece. And we said, how do we raise the bar of compliance? How do we really force companies to patch that bug quickly? And that can be, to be candid, is a reactive posture, and will always mean that we are at the mercy of our adversaries. But there's a harder question, which is, even if you're perfect at your compliance, even if you do everything right on time, you're not able to sleep well at night because you're not able to predict, the next undisclosed vulnerability that is just sitting and waiting and lurking in your product. And that is a really terrifying position to be in if you're a CTO or a CEO. And I think what we're curious to solve is, how do you get ahead of undisclosed vulnerabilities? And that is, I think, building off of a lot of the work that everyone here has been thinking about, requires a paradigm shift. And so our thesis really says, what are the ways you get ahead of undisclosed vulnerabilities? There's two key ways. The first one is saying we have to actually reduce the surface area that our adversaries have to play with. And right now we are giving them free layups. The net is just so big. Where you talked about the unforgivable bugs. I mean, we're getting laughed at, frankly. Because we're just making that an easy target. And so we have to figure out, how do we actually reduce that surface area, shrink that net? And that really means eliminating entire classes of bugs before they get into the product, not waiting for them to be patched. And this is, I think, building off the work that CISA has done, and many of our colleagues internationally have been thinking about. It's very heartening to come here and hear the words memory safety, informal methods, and cherry architecture being talked about.
Great?
It's wild to actually see that. It's amazing, because I think, a year and a half ago that was not the case. And it's very heartening to know this is a singular priority that we've chosen to focus on, which is, let's tackle this one class of bug that is got a high ROI if we tackle it. And the way we've explained it in our report is to say, this is a doctrine that I think can scale. So we said we want to secure the building blocks. Let's first tackle memory safety, and there are 3 building blocks that I think have been talked about already. One is the software building block, which in our estimation is the atomic unit of software is code. So what is the programming language in which you're writing in? And I think if you can ensure that your programming language is memory safe, then the things you build in that programming language will be memory safe. So yes, it's Rust, but it's also things like JavaScript, it's Python, it's Go, it's Ada, it's many languages that are memory safe. And so you've seen a push from the US and internationally to really unify our messaging on memory safe languages. The hardware building block, as many of you already know, it really kind of stemmed from the innovation here in the UK around cherry architecture, things like MTE. How do we actually architect our semiconductors and our chips to think about security from a hardware perspective? And then, as Sadie mentioned, there's actually a third building block, which is around mathematical reasoning, which is, how can we actually look at a system of system problem to say, how do we prove security, not test our way out of it? Because as any engineer will tell you, you're never done testing, but you can actually complete a math proof. And so what we're saying is, when you think about these are the core components of cyberspace, you're now actually able to apply that to a range of missions, whether that be securing our space systems, our national security systems, or our consumer goods, and everything in between. You're now having a consistent thesis to solve this that's rooted in technical and engineering. And then the second way we get ahead of these undisclosed threats is really saying, we need to better understand our software. Right now, it is very hard to ask the question, is there malware in this critical system? Answering that question is not something that can be done easily. And so what our thesis of why is there a market failure, we actually believe that it's not, as you mentioned, it's not caused because companies are like maliciously trying to harm our security posture. It's because we believe there's actually a scientific gap, and that we don't have the ability to understand what our software is doing and how it's performing, and that if we were to invest the R&D in the long term to close that kind of mathematical and scientific gap, then you can start seeing the supply chain and the market shift. And so a lot of what we're excited to see is, in the last year and a half, I think we've seen such a tremendous progress in our focus, both in the US and internationally, and it's really exciting to kind of see that if we really take a more technical and engineering-based approach to policy, we're going to actually get to the root cause of the problem.
Okay, so you've convinced me secure by design is a good thing. David, what's so hard about that? Tell me tell me about the customer experience, because I want to get back into customers asking for secure by design, but like MFA, removing admin, like there's all sorts of actual real world challenges.
I mean,
So, like,
there's
spin us
always
a tale.
this thing in like the room full of security people. Just do it, right?
Just do it.
And then you step out of this room and people are like, security is just one of 10 things I care about. And so I've done simple things in the market like introduce the TPM. Very basic thing. It would be cool if everyone had MFA and booted their device securely, right? This is like even I don't think there's anyone in this room that would disagree. But even that has unintended consequences, right? There's cost to go and develop that. There's performance issues that come with turning it on for the first time. There's compatibility issues, et cetera. And so very quickly you figure out who's really incentivized around security when those challenges come up. Another good example is if I go and were to implement a memory safety requirement or do things like hardware and memory tagging, it's not just a Microsoft decision at that point, right? The driver vendors have to get on board, the silicon vendors, that one line of business app you have from 22 years ago doesn't work. And then you really see, right, who's incentivized around security. And so I think that's the important thing for this, I think this group in the panel to conceive of is the calculus of doing things secure by design is much more complex than I think we like to believe because it's hard to reason about. And so what you have to do is actually decide that there's a commitment to something and that you only see the tip of the iceberg around the engineering problem. Like I want to start with Rust. Now I need a long-term serviceable compiler. I need to have code gen evaluation. I need to go and train people. I have to figure out how to interact with existing C, C++ code, right? I could go on because I've done this a lot. And so I think ultimately, I think it's really important for this group to not be naive about those things and start to build that into the calculus around what secure design by design really means, and then start to tackle some of the hard problems, like how do we do this lockstep? This group or some set of vendors may be very incentivized, but you have to have a much larger community around this. And I think that's where the problems start to get much, much harder.
And just building on that, the truth is we are probably a room of like-minded individuals, give or take. But this calculus has to speak to other parts of the business, the leadership. And one of the things I hear from people that are trying to make decisions about whether they will underwrite a massive business transformation from one platform to another operating system, training, tech, ongoing support costs, etc. They want to understand what the upside is, the why, the business case that connects security to the wider operation. So if your operation is putting oil in barrels, then make the case. And I think that perhaps we haven't enabled that case well enough yet as a community. People still struggle with it. The other thing they struggle with, and you only have to walk around the brilliant halls here to see why, because these kinds of events 20 years ago, believe you me, they weren't so busy, and those of you that were here, you would know what I mean. And people that are not the security specialists or the technology specialists, but still have a voice in the way in which investment happens in organizations, they don't know whether you should be buying this widget, that service. Is it necessary? Do we have to do it this year? Is it actually going to increase our security posture enough to be worthwhile? We're not doing enough to explain that. And actually, as a sector, we're getting really busy. There's loads of kit you can get. You can get hardware optimized to support security functionality. You can buy security service. You can buy stuff to put in racks, or you can buy software as a service online. And people don't understand how you orchestrate this stuff. And we're not enabling people to understand. So we're having a problem getting people to support us. We're beginning to sound like a sector that says, and has been saying for too long, things are getting worse. You need more of this. And yes, it does cost a lot. And that message we need to enable with a little bit more math, a little bit more business case, clearer explanations, I think.
Yeah, I think the challenge is that we still, we're a very complicated sector, but actually we're not the only sector that's very complicated. There's a lot of people where you can go around these sort of halls and get very complicated, very special language. But it is that disconnect. And some of that, something I've been bang on for ages, is that still it has the word cyber, it's technical. So therefore, that all sits specially in IT to look after, and there's a segmentation of thinking processes. And one of the things when you're looking at upgrading legacy, I've had many conversations with customers where they go, the person in the business unit that owns that app built on Windows Server 2012 that's using NTL MV1, they go, well, I haven't got the budget of 20 grand or 250 grand to upgrade that app. So therefore, the IT department carries on spending $250,000 or $500,000 supporting this legacy infrastructure, because it's like, oh, that's the business decision, that's the technology decision, and actually that technical cyber risk needs to become part of that business risk decision. It's a conversation it's a thing I've been on about for ages, but really it's true. So it's like, I've got this application, it shouldn't just be, can I afford the developers? You should have to pay your share of IT having to run that legacy to avoid you spending 20 grand upgrading your server.
That's a pretty spicy take.
And, yeah, I've said that more than once. IT should just cross-charge them. And that's an IT, not a cyber thing, because
Right.
if you look at a lot of that legacy that exists, it exists because someone's going, well, I had a bespoke thing. That's obviously evil, bespoke to many senses, because it just means legacy, day two. You know, I got someone in to build it. The minute they walk out of the building, that is a legacy system. But effectively, you need to be thinking, when I put something live, how do I maintain it? How do I keep it going? And how do I keep it working? And that's why, yes, we as a business need to be much more giving advice, just like a CFO or financial department would give advice on financial risk. We need to do the same. But also the business needs to start saying, if I'm going to do some digital transformation, here's the opportunity that comes with it, and that there's also the threat. Now, I'm not always going to get all the threat right, but at least make an attempt. So it's not just about secure by design, it's about when I'm making business decisions, I'm thinking about the threat as well as the opportunity, so I can manage the threat to maximise the opportunity. And yes, we're a little bit to blame because we use long-winded words and jargon, but I've occasionally sat in listening to financial accountants, and I don't understand what they're saying either. Everyone's got their own jargon. So.
I don't think it's just jargon and long. I agree, but it's not just that. It's that I think we, including myself as a community, we don't always understand
Yeah, no, we
the
have to think
optimal way to configure things.
I
We
think
don't have the data.
You know, I'm going to be somewhat self-critical of us in this room. We bemoan, like, why isn't this a boardroom priority? Why? And it's like, well, it's not their job to come care about cyber. It's our job to care about their mission. Whether you're talking about a national security mission, like, we need to forward deploy to those use cases to understand why it's hard. And on the business side, the mission is, yes, it's innovation. Yes, it's profit. So we can't go to the CEO and have them try and care about incident response. That's not their job. It is not their job to think about the reaction after the incident. We need to go to them and frame cybersecurity and secure by design as a manufacturing imperative, as an architecture decision, not as a compliance activity. Yeah. And I think this is, candidly, we've been selling to the CISO, who, God bless them, they have such a hard job putting out all these fires. We need to be talking to the CTOs and saying, hey, as you're building your tech stack of your product, what are the choices you're making? Like, go talk to the OEMs and say, yeah, use Cherry, use MTE. And I think, to the question of, what does this mean for small businesses? I actually think secure by design and secure building blocks is like advantageously in favor of startups, because not only are they probably already doing these things already, but they don't have the legacy problem that their incumbents have. And so we should be going to venture capitalists and Silicon Valley and the startup community and pointing to this and saying, you're trying to sell to the US government, the UK government. This is your competitive advantage. You're selling on security as your core value proposition, because now you're not having a conversation about legalese and do you have a big enough team of lawyers. You're now saying this is an engineering proposition. And I think that goes back to why it's so important to remain technical in cyber policy, because otherwise we're using compliance as our only tool.
Right, exactly.
I just going to say, I think it goes both ways. So we need to think about how to enable the business. And I've heard too many times, I don't want the company doing cloud, mobile, insert new technology here because it's too risky. No, it's too risky for the business not to do it. But at the same time, from a business perspective, you have to be saying, not just let's do it. How do we do it securely by design?
Yeah, so I think you're touching on something interesting. So I've had people ask me questions like, Bobby, if we actually had all of the different parts of the ecosystem build things to be secure by design, your laptops would cost $10,000. And I think embedded in that is some misunderstanding of what we're looking for. So help me formulate an answer that I can go back to these fine folks who are, by the way, they're not being like satirical. This is part of how they process what we've given them. So to your point, are we actually teaching them how we think, or are we failing in some way?
I mean, and I think this is why memory safety is such a great starting point, because you can actually now quantify and point to and saying, look, how many of these CVEs are memory safety bugs? Up to 70%. Okay, so if you actually use Rust, for example, you solve that problem. Like, how much does that cost in terms of engineering costs? You know, you're making using a memory safe chip, and you're getting that into your products. Okay, can you still go to market on time? Okay, great. You got security and economic advantage. Great, sell them on that.
I don't think people buy that, though. I think that's part of the problem, is we've not done a good job of communicating to them to explain that the cost of redo work is substantial, and that playing whack-a-mole is more expensive than doing fully thorough root cause analysis and then making hard business decisions like the change programming languages. Like, I think we just haven't made that level. So again, help me with any talking points on how to process.
I mean, there's evidence proofs that that's just not the case, right? If you take, there are Android phones out there that have MTE, hardware root of trust, are compartmentalized, have virtualization. I mean, basically have everything.
And they're not
$10,000. And they're not $10,000, okay. Like $350. I have one in my bag over there, right? Okay. And so that idea that somehow this adds the cost, I think, is just fear, uncertainty, and doubt. And if you really want to start analyzing the costs, right, secure by design is just a fraction of the kind of cybersecurity world. Most people out there are selling very expensive detection solutions that sort of propagate, like, you don't actually have to fix the design. We'll just bolt on this AI thing, and that's somehow going to detect and fix everything. So you really were about cost optimization, fixing it upstream. Again, I think that's one of the core sort of principles here, is the more you fix it upstream, the cheaper it is. And so, I mean, the reality is, if you just took mobile, right, you could buy this, some of these phones for that are very cost effective, that have high compute, et cetera. And the vast majority, if you were to take sort of the MITRE attack framework, the vast majority of those attacks are fully mitigated deterministically, and the cost savings on the back end in terms of detection are enormous. So I just think that's just not a good argument, frankly.
Okay, let's get spicy, because they're two different things, right? I mean, I totally agree
Sort of.
that if you harden your system and you remove vulnerability from the get-go, of course, that's way cheaper than having to change it in motion. But that doesn't actually remove the threat. It just removes a particular part of the attack surface that the threat was going after. It's still going to be there. So we're still going to need threat detection. Possibly even worse than that, we're going to have a bit more sophistication for a while it gets innovative, because some of the attack surface has gone down.
But we can get rid of the chuckleheads.
Because there's still money to be made from
chuckleheads.
cybercrime. But this is what I mean about the complicated jigsaw puzzle. Of course we are going to need threat detection. Of course we are. Because you can never assume you've got rid of all the attack surface. And anyway, even if you've got rid of all the memory problems, and somebody really wants to get you, they probably have a member of staff on the inside, right? So,
but that's what we're trying to do.
We're always
in
going to need some threat
But that's what we're trying to do in
trying
security. We're trying to raise the cost of attack.
To get spicy again, going back to the being old people in this industry, I remember, 20 years ago, it was all about complete prevention. Stop it getting in.
Yep.
We're going to do it. And that's when you had the whole lockdown approach and, supposed security.
delusion.
It was delusion. Complete delusion.
Zero trust now.
Yeah.
By the way.
It was the complete delusion.
Because it worked.
Yeah.
hallucinations working with AI,
It was the
right?
complete delusion, while pen testers like our company were breaking in left, right and centre, but still we got protection, right? And then everyone went, we're spending too much money on that, so we need to do more money on detection response. I remember it was 80% prevention, tiny little bit. I mean, SIMs weren't even a thing at the time. You had a few managed security service providers. Then we've gone detection response. And now we're probably 80% detection and response. And then we're now talking about prevention. And let's be fair, we need to do prevention, detection, response, and recovery if we're going to have true resilience. Yeah, always.
Yeah.
But the problem is that the one thing we do have in our industry is we follow the sexy, while at the same time carrying on doing the deeply unsexy. So that going back to the unforgivable vulnerabilities, the question is, why do we still have it? Is it because everyone thinks $10,000 because they don't know, so they're sticking a finger in the air, and we have comfortable ways of working? So we still got the unforgivable vulnerabilities because the one thing that's a constant is that as human beings, we get into a nice, comfortable way of working, and we know how to do that, and we don't like to change. So we all pivoted to detection response, and now we need to. The working across the world and working holistically is not naturally how we work. We get into grooves, and that's probably the challenge of why we still got, and so why everyone's concerned about any new change or any new approach. If you look at people going to cloud systems or mobile, they still try and do things. If you look at the average security architecture, it's still the security architect of the year 2000 when you had a VPN and firewalls and that whole delusion of lockdown security. And yet you're trying to do that in a hyper-connected cloud mobile world. We need to change the way we do architecture, which is the thing we're talking about a lot. And then we need to change the way we do architecture, both from systems design architecture, but also just straight up security architecture. But we have comfortable ways of working, which is why you're saying, yeah, we still need detection and response, yes, but let's not get too comfortable with that. Let's look across the...
Yeah, but there's still super strong evidence proof that secure by design and lockdown is effective.
Yes.
The most
100%.
numerous compute devices in this room right now are mobile phones, and the attackers are completely asymmetric there. It's multi-million dollars for a
100%.
mobile exploit chain. And sure, most people at enterprise level would have detection on their phones, but that detection is very cost effective. Now, an anomaly is actually an anomaly.
Yeah.
And I don't have to collect gobs of data and spend gobs of compute time, killing the planet to run through that. In fact, I have a much smaller stream and it's much clearer. So I still think the cost effectiveness is very clear, and it's probably mobile, which is the closest I would say to achieving secure by design, is clearly the only place we're actually asymmetric in cyber, which is it costs way more to attack a phone than it does to fix it. So I'm always surprised that we don't see that as like the place.
I think
that we
one
should be
place
putting
where you
more
get a
energy.
market advantage is
Yeah.
actually now selling on developer experience.
Yep.
So like I think
Right.
this is where, and I'm sure this is you live this at Microsoft, right? Why is Rust such a great nexus for like cyber policy and engineering? It's because developers want to write in Rust.
Yeah, that's huge.
And so if
Yeah,
you can
that's huge.
optimize on product development and security solutions that, yes, are security, but are just like, amazing user experiences, like that's how we win in the market. Because fundamentally, your engineers are just like caring about that. So I think for us at the White House, kind of where we've spent the last 18 months is saying, okay, how do we make the connection to show that memory safety vulnerabilities is like a national security imperative? I think we've succeeded in getting the right people's attention on that.
and
The next chapter for us is saying, how do we make this like the best developer experience to make every engineer and every private sector company wanting to do this, going to companies that are choosing that tech stack because they prefer to do it. And that's the mission, I think, for the security industry is focus on user experience, focus on good engineering, and make that security outcome in tandem with that, not in competition.
Totally agree about that.
Unfortunately, just as we got spicy, we got to wrap it up. We have to do another one of these. Can we do another one of these? They just got really spicy. Thank the panel very much. I really appreciate all of your advice. So thank you.
Very Sadie.
Paul's supposed to do a bit on that as well.